Right, shalom. That is the entire limit of my knowledge of Hebrew. So unfortunately, this presentation will be in English. Trust me, you don't want to do it in Hebrew because shalom, shalom, shalom does not work well. Right. My name's Tim Faulkes. I am the Chief Developer Advocate at Aerospike. That means that I talk to developers and help people with their applications all day, every day. I've been at Aerospike since about 2015, written a good number of patterns, wrote a book on Aerospike. So are there any developers in the room? Oh, excellent, good, because I was wondering, well, this is all going to be for you guys. I was really terrified there's one person going to raise their hand and sneak out as I started talking. So what I want to do is talk a bit about Aerospike. Now, obviously, we've just heard a couple of presentations. You guys understood a lot more than I did. I learned that random access is actually a Hebrew word, but that was about all I got out of those presentations, but they looked really good and impressive slides. So I'm not going to tell you what Aerospike is. What I'm going to do is focus a bit more on the developer side of things. So back in 2009, people started Aerospike. First production deployment was 2011. And it started as a very simple database. It could do gets, it could do puts. It was really good for ad tech and people like that. It was a very simple API layer by design. It's designed to be really easy to use. One of the things that we decided to do was make sure that everything was customizable. So we knew that different use cases had different requirements. Some needed really fast reads. They could sacrifice consistency for the speed of reads. Others needed slower reads, but it always had to be the right data. So we had a policy. So we've got a very simple API which has get and put. Everything took a policy. And the policy controlled things about what happened when things went wrong, because things will always go wrong, particularly in a distributed system like Aerospike. So it contained, do you want to retry this operation? How many times do you want to retry it? How long do you want to wait between retries? All that good sort of stuff. Now, I was an engineer for 20 plus years. I'm not going to tell you how many because I'm really old and I don't want anyone to know that. I didn't care about databases. When I was an engineer, a database was a necessary evil. I wanted to go and put information in and get it back. I didn't want to think about how it worked, and I certainly didn't want to think about network settings for it. So we had this policy, and developers, well, certainly at my level, didn't care about it. They would always mess it up. So it's very critical information to the database, but developers weren't so keen on it. I put this interesting graph here because I didn't know if anyone was going to talk about Aerospike. I didn't know if people knew about Aerospike. This is actually a graph from our customers. We've heard some really cool things about what Aerospike can do. This is an actual customer moving from another NoSQL database to Aerospike. This is their latency on Aerospike. It's just above the axis. That's about 250 microseconds. That's application to database and back. Just validation for what we've heard before. All right. These policies are great. They're absolutely needed. But then I've worked out that the Aerospike developers at some point were a bit like children. Does anyone have children here? Good, only a few people, that's terrifying. My children were like, here's a box. I need you to go and put books in it. Only put books in this box. And you come back 3 hours later and there's books and there's toys and bits of tin foil, bits of gum and all sorts of random stuff in there. And you said, well, what happened to only the books? They went, it was there. We had these policies in Aerospike. As we got more and more advanced and added more and more features, we added more things into those policies. Things that didn't necessarily belong in that box of books. So things like, if I'm doing a write operation, I want to do a check and set. I want to make sure that I'm writing this record, but the server shouldn't accept that write unless it has changed. If it hasn't changed. So that went into the policy. We got this concept of filtering expressions. I want to perform this operation, but only if this is true. That went into the policy. Transactions just arrived. They went into the policy. So the policy started off being very dedicated to this set of things developers didn't care about. And then they moved into something that the developers really did care about. They care about transactions. They care about check and set. We then got queries. And queries added a whole new sort of complexity because they said, well, we need network settings, but there's also other things that we need. We need to know which namespace you're looking at, which set, what sort of tables, what are you scanning. And so they gave us not one box of very useful information, they gave us 2 boxes. And sometimes they put things in the wrong box and got even more muddled. So the API that we have was this way for a good reason. We had to maintain backward compatibility. Because everyone's using our database, if we start adding parameters for these new wonderful features that we're creating, people's applications break. We can't go and change the types. It becomes brittle. And so these policies were changed for a good reason. We also found that over the decades, the languages became they changed what became idiomatic. So I'm a Java expert, and Java has changed dramatically. We don't use arrays, we tend to use lists, there's optionals, there's all sorts of good things that have changed. So our current API looks something like this. There's a lot of big code, and all it's trying to do is I've got a customer and I want to go and load all their accounts, but I only want to load the accounts which meet balance greater than $500 or a status of active. And so in this horrible mess of code, we get the customer, we check to see if it exists, we go and find out all the keys of those accounts, we go and create a set of keys to go and load those accounts. We have an expression which says, here's the accounts that I want to match. And then finally we go and get them, and then we sum up all the balances across them. So there's a lot of code to do something that's very simple to talk about. And so our DevOps side is very powerful. We're designed for all the failure scenarios. We can just keep running under all circumstances with sort of latencies that we've been talking about. But we wanted the developers to have a better experience. This is a lot of code to do something which is fairly simple. So we decided to try and make a new API. Now the requirements were fairly practical. I wanted someone who has not touched Aerospike before to come along and say, I like this. I can understand what Aerospike is doing. It has to be really simple for beginning people. But I really wanted it to be very powerful for experienced programmers. And that's a hard dichotomy to try and come across. I wanted the developers to focus on what they cared about. That is their application. They don't care about the network settings, so I don't want them to ever have to worry about the network settings. In our queries, those index queries that I spoke about, you have to tell it which index you're using. Now, if you've used other databases like relational database, you don't, as a developer, have to do that. Someone else's job is to say, I'm going to optimize this query by selecting, putting an index on it. Currently, we have to do that. These days, LLMs are all the rage. AI is definitely going to be part of our job as developers coming forward. So we want to make the new APIs very AI friendly. We'd like them to be able to understand and help you write code. If you ask ChatGPT to write you something in Aerospike at the moment, it does a good job, but it's not a great job. We'd like to make it easy enough that ChatGPT can do a great job on it. Fundamentally, they needed to be readable, maintainable, and extensible. All the traps we'd fallen into in the past, we didn't want to fall into again. We wanted it to reduce boilerplate, so only the stuff you need to write, and we want to make it discoverable by the IDE. As a developer, you have a tool set. We want that tool set to help you write your applications. And from this, we effectively derived what we're going to call the Fluent API. It's using a programming style called Fluent Patterns, and it becomes much more readable. So this is a simple update in our new language. So effectively what we're saying, hopefully even people who haven't used Aerospike can read that top bit of code. Session update, customers, ID 1001, set bin status, set to paid, bin balance, add $500, and go. So it becomes very simple. There's nothing in there that's talking about policies or network settings or anything like that. This becomes very discoverable through the IDEs. At every point, I can say to the IDE, what can I do next? So I enter session.query users. I put a dot and it will tell me, well, you can say where or limit or reading only bins or things like that. So it really helps the programmers discover what actions they can take. Rather than having to put in lots of obscure parameters to try and control something, the IDE will help. We want a terminal method. The one slight drawback with a Fluent API is everything I do up to my execute statement is telling it what you want to do. As soon as I say execute, it will go and do it. Now, the nice thing about this is I don't have a lot of parameters to any of these methods. They're all optional. If I've got something that's mandatory, then I can force it to be specified. But all the optional stuff, I can add new things to it. I can remove things from it. I'm not having one generic collection of box of books. I'm effectively saying, yes, I can do this small part or add something here and change it without breaking anyone else's code. So backward compatibility is easy to maintain. But those policy settings, those network settings that we spoke about, they're really important. But not to a developer. They're important for Aerospike to know about and probably for your DevOps people to know about. So what we're going to do is we have abstracted them away. So we have this concept of a behavior, and a behavior encapsulates all the network settings. But they're more flexible than the current policies. In a typical use case, people don't just want one set of policies. I might have a read that I need to do. It needs to be very, very quick. If I'm doing ad tech, for example, I need to get my information about who's the person who's showing some space on the screen, get that information in 10, 20 milliseconds. So I might say, try and get it in 10 milliseconds. If I can't, go across to another node and get it again. But then I might look at account spending. That needs to be accurate. I can spend more time on it, but I need it to be accurate. So I probably have multiple different sets of policies. Behaviors encompass all of this. And the nice thing is they're controllable. The DevOps people can have a file which overrides all the behaviors in your application code. So I don't need to specify them. I put them in in a behavior, and then someone else can manage that for the developers. Once I've done this, developers do not need to think about these policies. So it's really flexible in terms of control. One of the big drawbacks of a Fluent API is it's really hard to work out what order you need to put things in. So I've got flexible. So I'm doing something like I've got a session, I want to query key 1, I want to say respond all keys true and with no bins. Now, when I create my API, I define it with different interfaces, and these are done at different levels. So everything has a reading only bins, everything has a with no bins. But the only one which has respond all keys is a key-based query builder. If I'm using an index, I don't need that. So if I do in this order, my query key 1 returns me a key-based query builder, respond all keys returns me a key-based query builder, and that gives me, with no bins, returns a query builder. That all works beautifully. But if I swap the order of these, it starts breaking things. That's really bad. If I put no bins first, it says, oh, that's on query builder, I return a query builder. But I then want to put the respond all keys, because I'm not trying to mandate, I'm trying to help. And this would mandate the order of actions, and that's just wrong. So to solve this, we've got these patterns of self-referencing generics. It makes sure that you have the right types at any point without the developers having to think about it.
Well, what language is this?
That's all Java. So we're doing Java and Python first, but the aim is that if they're well accepted and people like them, they'll move on and do other languages like Node, Go, and so on. All right. One of the nice things about this is you can do powerful things. Aerospike is super powerful, but we've done a bunch of things to make sure that the client-server protocol is as fast as possible. That means error messages don't necessarily come back the way you want them. So I've got some parameters which can break Aerospike. If I look at my top line of code, effectively this big messy line is saying, I've got a set of rooms and I want to get any rooms in the keys room 2 to room 4, but I want every key actually outside that. Works beautifully. The second line looks very similar. The only difference is I'm using get by key and passing it one value instead of get by key range. But as soon as I specify the inverted flag, it breaks. It gives me an error at runtime. The hardest sort of error to debug. It's just nasty. With the new API, I can force those sort of combinations to be invalid. So these give exactly the same thing. They're exactly the same functionality. It's simpler code. But this will actually give me a compile error on the line that is invalid because I can't invert something which only gives me one result back. So it means that I get compile time errors instead of runtime errors, which makes a big difference to the developers. All right, so this is an example of what the new APIs will look like. It does exactly the same thing as that original bit of messy code we saw. So first thing I do is I'm going to go and query the customer data set, execute that, and get the first instance of it. That gives me a customer. Hopefully most developers in the room can look at that and say, yeah, I can see what that's doing. If that was there, then what I'm going to do is I'm going to get my customer record, get my list of customer account IDs, do a query on that, and I've got a where clause. One of the things we're introducing is this concept of a domain-specific language where instead of having to do big, ugly, horrible expressions, I can describe something in a program that will understand, like balance greater than 500 and status equals active, and Aerospike will work it out. Now notice in that line, I'm not specifying what the indexes are. Remember I said we wanted to separate out the DevOps and the developer side? The policies went away, and this means that Aerospike will work out which index to use and what else to add on to get the correct answers. You don't care. You could add a new index at runtime and you wouldn't have to change a line of code. So it makes developers' life substantially easier. And then I'm just getting that and using standard Java streams to work out the sum of this. So very idiomatic Java. So pros and cons of the new API. It's natural language. You should, as a developer, be able to look at it and understand what it's doing, even with low Aerospike experience. The aim is to give you compile time safety instead of runtime catching of errors. Runtime errors are really hard because you might miss them. Compile time errors, you are guaranteed the compiler will pick them up and make sure you're doing the right things. Better maintainability. It's really easy to maintain because it's readable and someone who hasn't seen the code before can understand what it's doing without having to spend a long time trying to identify it. We have better IDE discoverability and making sure that it's working well with AI tools. And things like cross-cutting concerns like logging, it gives us an easy place to put that. There are a couple of drawbacks. From the people who designed the API, that's me, it's a lot more work. We have to think about all the catches and everything we can do, make sure you can do only valid operations. But the nice thing is that's for us to worry about. A fluent API has more API code, but again, we write the API. The users of the API, that's you guys, have a lot less code. There is more memory allocations. They tend to be very short-lived. Most languages, including Java, are very, very good at short-lived allocations. So I don't think that's a real problem. And it's not increasing the amount of memory. And testing is slightly different. If you want to mock Aerospike or test it, then you use a different library. But fundamentally, the ability to have backward compatibility and the problem I spoke about at the start, removing that problem makes sure that we can keep evolving Aerospike, giving new and better features without breaking anything that you've written in the past. Plus, it's easier for you guys to write code. Any questions?
When is it coming?
For Java, when it is coming is the question. For Java, there is an active preview out there. There is a GitHub repository which has a fully working API. It's not something you put in production. When is it coming? So you can go and play with this today. There's actually a workshop which you can go and play with it and create a real application using this. Please don't put in production. It's not production ready code, but it's certainly something that I'd love to get feedback on with you playing with. Python, we're close to that, and they're the first two languages we're working at. Any other questions? All right, thank you.